Welcome back to Operating Systems Crashcast. I'm Victor, and with me as always is the brilliant Sheila. Today, we're wrapping up our discussion on deadlocks by exploring an essential topic: recovery from deadlock.
That's right, Victor. We've covered various aspects of deadlocks, from prevention to detection. And now we're diving into what happens when a deadlock actually occurs. How do we get our system back on track?
Excellent question, Sheila. When a deadlock is detected, the system needs to recover from it. There are two main approaches to deadlock recovery: process termination and resource preemption. Let's start with process termination. Can you explain what that entails?
Certainly. Process termination is exactly what it sounds like. We end one or more processes involved in the deadlock to break the circular wait condition. There are two variations of this approach. First, we can terminate all deadlocked processes, which is a bit like using a sledgehammer to crack a nut. It's simple, but can be quite costly in terms of computation that's lost.
That does sound rather drastic. What's the alternative?
The alternative is to terminate processes one by one until the deadlock cycle is broken. This approach is more conservative and can potentially save some work, but it requires more overhead as the system needs to run the deadlock detection algorithm after each termination to see if the deadlock has been resolved.
I see. So it's a trade-off between simplicity and potential waste of resources. Now, you mentioned resource preemption as the second main approach. How does that work?
Resource preemption involves temporarily taking a resource away from a process and giving it to another process to break the deadlock. It's like if you had two kids fighting over a toy. You might take the toy away from one and give it to the other to resolve the conflict.
That's a great analogy, Sheila, but I imagine there are some challenges with this approach in an operating system context.
Absolutely. There are three main issues to consider with resource preemption. First, we need to decide which resources and which processes to preempt. This isn't always straightforward and can impact system performance.
I can see how that would be tricky. What are the other issues?
The second issue is rollback. When we preempt a resource from a process, we need to roll that process back to a safe state, which is a state where it doesn't have the preempted resource. This is where the concept of checkpointing comes in handy.
Checkpointing? That sounds interesting. Can you elaborate on that?
Sure. Checkpointing is a technique where the system periodically saves the state of a process. If a deadlock occurs, and we need to roll back a process, we can return it to its last saved checkpoint. It's like creating save points in a video game. If you die, you don't have to start from the very beginning.
That's a clever approach. And I assume the third issue has to do with ensuring fairness in the system.
You're spot on, Victor. The third issue is starvation. We need to ensure that the same process isn't always chosen for preemption, as this could lead to that process never completing its task. It's important to have a selection algorithm that's fair and doesn't consistently victimize the same process.
These are all crucial considerations. Now, thinking about real-world applications, can you give an example of where deadlock recovery might be particularly important?
Certainly. Consider a database management system handling multiple transactions. If a deadlock occurs between transactions, it's crucial to resolve it quickly to maintain system performance and data integrity. In this case, the system might choose to roll back the youngest transaction, as it likely has done the least amount of work.
That's a great example, Sheila. It really illustrates the practical importance of these concepts. Now, as we're wrapping up our discussion on deadlocks, how would you compare recovery to the other deadlock handling strategies we've discussed in previous episodes?
That's an excellent question for tying everything together, Victor. We've discussed deadlock prevention, avoidance, and detection in previous episodes. Recovery is really the last resort when all other strategies have failed or weren't implemented. Prevention and avoidance aim to ensure that a deadlock never occurs in the first place, while detection and recovery deal with deadlocks that have already happened.
Right, and I imagine there are trade-offs between these different approaches.
Absolutely. Prevention and avoidance can have higher overhead during normal operation, as they're constantly working to prevent deadlocks. Detection and recovery, on the other hand, allow deadlocks to occur, but then take action to resolve them. The choice between these strategies often depends on the specific system and its requirements.
That makes a lot of sense. As we conclude this episode and our chapter on deadlocks, what would you say are the key takeaways for our listeners, especially those preparing for interviews?
Great question, Victor. I'd say the main points to remember are 1. The two main approaches to deadlock recovery: process termination and resource preemption. 2. The challenges associated with each approach, including deciding which processes or resources to target, how to roll back processes, and how to prevent starvation. 3. The importance of checkpointing in facilitating rollback. 4. The trade-offs between different deadlock handling strategies, including prevention, avoidance, detection, and recovery. 5. Real-world applications, like in database management systems, where deadlock recovery is crucial.
Excellent summary, Sheila. I'd also add that it's important to understand that there's no one-size-fits-all solution to handling deadlocks. The best approach depends on the specific system, its requirements, and the potential costs of deadlocks versus the overhead of preventing them.
Absolutely, Victor. That's a crucial point. Understanding these concepts and being able to discuss their trade-offs and applications is key for anyone working with operating systems or preparing for related interviews.
Well said, Sheila. And with that, we wrap up our discussion on deadlocks. Thanks to all our listeners for tuning in to this series on process management. In our next episode, we'll be moving on to a new exciting topic in operating systems. Until then, keep your processes running smoothly.
And remember, in the world of operating systems, a little deadlock recovery knowledge can go a long way. Thanks for listening to Operating Systems Crashcast.